Welcome, everyone. Today, we're diving into a really powerful way to manage your large language model's context window, MCP Tool Search. If you feel like your model's memory is getting clogged up before you even get started, this is for you. So here's what we're going to cover. We'll kick things off by looking at a big problem that a lot of developers run into. Then we'll introduce the solution, which is dynamic tool search. We'll see how it works under the hood, I'll walk you through how to implement it, and then we'll wrap up with some best practices and common pitfalls to avoid. All right, first up, the crowded context problem. This is something you'll definitely see when you start connecting your language model to multiple MCP servers, each packed with, dozens or even hundreds of tools. See, the way it usually works is that when you connect to a server, it loads the definition for every single tool right away. That's a huge chunk of your context window gone before you've even asked a single question. It's like packing your entire toolbox for a 5-minute job, just inefficient. And to give you a real-world example, just look at the GitHub MCP server. It's got 91 tools. The moment you connect, bam, that can eat up 46,000 tokens. With a model like Claude 3 Opus, that's almost a quarter of your entire context window vaporized right at the start. Yeah, this really says it best. Imagine just dumping every tool you own onto your workbench all at once. It's just a cluttered mess, and that's exactly what this preloading does to your context window. It pollutes it, leaving less room for the actual conversation. Okay, so that's the problem. And that, of course, brings us to the solution, a much more elegant, dynamic approach called MCP Tool Search. And this comparison just lays it all out, doesn't it? The old way, on the left, is to load everything up front. It's costly and messy. But with Tool Search, on the right, you start lean. You only load one simple search tool. Then, when you need something, it dynamically finds and loads only the 3 to 5 most relevant tools for the task. The result of this on-demand method is pretty staggering. You're looking at a potential token reduction of up to 85% for your tool definitions. That frees up a ton of space in your context window for what really matters. So, how does this magic actually work? Let's get into the mechanics and see how it builds a much smarter workflow, from the user's query all the way to getting the job done. It's actually a really simple but powerful 3-step process happening behind the scenes. First, the model figures out what the user wants and creates a search query. Then, the system scans your entire catalog of tools to find the best matches. And finally, it loads just the top 3 to 5 tools into the context. It's all seamless. And you've got 2 main ways to search. Think of regex search like a librarian who knows the Dewey Decimal System by heart. It's perfect when your tools have really consistent, predictable names. BM25 search, on the other hand, is more like asking that librarian for books about space travel. It's a keyword-based search that's great when your tools have more descriptive, varied names. All right, now for the really good stuff. How you, as a developer, can actually put this into practice. We'll look at what you need to do on both the server and the client side. This quote right here is the golden rule for the server side. Your #1 job is to make your tools findable. Think of it this way. The tool's description is what helps the model discover it. The schema is what helps the model use it correctly once it's found. And this is where you have the most leverage. Writing good tool descriptions is absolutely crucial. Start with the function, what it does, keep it short and sweet, sprinkle in some good keywords, synonyms are your friend here, and please keep technical constraints in the schema, not the description. And remember, every single word costs tokens, so you have to be ruthless. You can also use something called server instructions. This is basically a system prompt that gives the model a little guidance. For example, you could tell it, hey, for anything related to a pull request, always check the PR status before you search for a tool to approve it. It just helps the model know the right order of operations. Now, on the client side, it's just a straightforward 4-step process. Super simple. First, you enable the beta header in your API calls. Second, you add the search tool itself, and make sure this one is always loaded. Third, you tag all the tools you want to be loaded on demand. And finally, just leave your 3 to 5 most used tools untagged so they're always ready to go. That's it. Okay, let's wrap up with some key guidelines and a few things to watch out for to make sure you're getting the most out of this feature. So when should you reach for tool search? Well, it's a no-brainer if you're working with, say, 10 or more tools, or if you notice your tool definitions are eating up more than 10% of your context. And of course, if you're looking to cut down on token costs, this is a clear win. But look, it's not a silver bullet for every single situation. If you only have a handful of tools, or if all of your tools are used constantly, you might just stick with preloading. Same goes if every millisecond of latency counts, because the search does add a tiny, tiny delay. And finally, a few common traps to watch out for. Trust me, you want to avoid these. First, never, ever defer the search tool itself. It has to be there to do the searching. Second, don't make your descriptions too vague. Get whether is just not enough information. And third, resist the temptation to mark everything as essential, because that completely defeats the purpose. So we've gone through the problem, the solution, and how to make it all work. After all that, there's one core idea to take away from this. And it really all boils down to this. We need to shift from static, bloated context windows to a more dynamic, efficient approach. Stop wasting precious context by preloading tools you might not even use. Start searching for them on demand. It's a simple change that keeps your model lean, focused, and ready for the actual work.